Hi there, it's nice to see everybody. It's nice to be back at DevOps UK. My name is Carly Richmond, and today I'm going to talk about retrieval. I'm going to talk about retrieval in the recent past in terms of the area in AI and also what's happening now and potentially a little insight of what's going to be coming next. So I'm going to talk about why retrieval is important and still needed. We're going to talk about RAG, so quick show of hands, who knows what RAG is? Who knows the difference between like vanilla RAG and agentic RAG? By the end, we'll all know what the difference is. We're going to talk about re-ranking models briefly. Who knows what re-ranking models are? Again, we'll all know by the end. And we'll also talk about BM25 and vector search and the differences. So by the time we come out, we should all know all of these things. If you haven't met me before, it is lovely to meet you. My name is Carly Richmond. I lead the developer advocate team. I work at Elastic. I've been there for 4 years, which is really weird to say, but in a good way. And I collect, since I work in DevRel, I collect socials like Pokemon. So if you want to find me, just find wherever I am on that Linktree QR code. But I'm also at the booth, so come and chat and say hi afterwards if you've got questions, because with a 50-minute slot, I doubt we're going to have time with me going through everything for questions. So come and chat and say hi. I'm friendly, and honestly, I don't bite. So who's heard of context engineering? It's been the buzzword over the last year. Basically, this is the idea of us trying to figure out what information we need to pass into an agentic system to make sure it's got the right information. That's what context engineering is. Because we're building stuff like this. So this is a really simple Yoda agent. It would be rude not to, given it was May the 4th recently, where we're talking with Yoda. He's able to tell us information through this remember tool about, how Luke learned the ways of the Force, and he's also able to move an apple as well using the Force, as you can see from this particular example, where he's going to go off and actually, perform a workflow action. So we're not just talking about the notion of pulling in data, we're also talking about performing actions with these agentic systems. But in order to know what's going on, LLMs have something called the context window. Are we all familiar with the context window? Okay, a few of us, but not all of us. It's really simple. It's the number of tokens that an LLM can process at once. Think of it as its memory, right? So the idea of context overflow is something we talk about a lot. This idea that there's too much in the context window and the LLM's therefore not going to pull it into its context and know what's going on, and it's not going to use that piece of information. But thinking about this entire pool, the quality of the data that we put into the whole context is going to have an impact on what the agent does. If you put in information that's incorrect, if you poison it with, problematic context, all of these things are going to lead to your agents doing the wrong thing or not what you expect them to do. And that's what context engineering is for. So this is a set of techniques that we can use to pass in relevant context into our systems. And they vary from things like the user prompt, the instructions that we write for our systems themselves, RAG, which I think half of us knew about, tools, memory, and also the outputs as well. Because our job, in my opinion, is evolving into basically trying to structure the right information for these agentic systems so that they end up performing the right actions. Because I don't know if anyone realized this. Has anyone ever had an LLM spit out something that was wrong or incorrect? I thought there was going to be more hands. I'd love to see what you guys are asking LLMs if less than half the room. I have had this. LLMs make things up and they hallucinate for several different reasons. It can be down to the state of the training data and the knowledge it has. If it's limited, if we have a model, for example, that has the cutoff date of November 24, and I ask it what happened in the football last night, it's not going to know. So we have the notion of cutoff point in terms of, of publicly available information, but also private information from our companies. If we're using smaller models or models that are perhaps trained on specific cases, we can suffer from something known as overfitting, which is basically where the parameters are too tight and focused on the training data and don't have the flex to resolve to our given problem. There's biases in the data set, not just relating to gender, but all sorts of other protected characteristics that can influence an agent. And if we end up with agents, for example, that are making loan decisions and we find out it's based on, it's turning down people based on these protected characteristics, we have a problem. There's language ambiguity. Anyone who's had to help like a young kid with reading knows that the English language is full of it, and it's actually quite difficult sometimes to discern from context. And then there's this really wacky thing called catastrophic forgetting, where they just forget realms of training data randomly, which is a little bit scary. But one of the big things is that they have been incentivized. At least that's surmised by these guys at OpenAI and Georgia Tech, who put forward last year that one of the main reasons LLMs hallucinate is because the training and evaluation procedures have incentivized them to do that. So just like anyone who's had to take a pet to obedience classes or is trying to, kind of raise a child, if we're rewarding the wrong thing, why are we surprised that they go back and do it? It's the same thing for an LLM. Now, we need to therefore know how to get the right information into these agentic systems. And the way we always talk about doing that is RAG. So for those who weren't familiar when I asked earlier, RAG stands for Retrieval Augmented Generation. It's a fixed pipeline. It goes off and fetches results, normally utilizing a vector database and semantic search, but not always, as I'll make the argument for, to pull out the relevant documents that we want, that therefore are going to be passed into the context window. The problem with this is that it gets called exactly once. It gets called no matter what, irrespective of whether we need access to that data in order to perform the task. And also, if we need more information, it's not going to go off and recall and try and do something else. It's a fixed pipeline. It often uses vector search. So who's familiar with vector search? There's normally been a few talks at Devox in prior years. So half of us have and half of us haven't. So vector search is basically where we generate a stream of numbers known as an embedding or a vector. Simple one like this. Nah, they're more complicated than this. They're normally typically a higher dimensionality. And each of these numbers represents a feature within that particular piece of data. So in my example here, I've got a two-dimensional vector space based on kind of realism and obviously human versus machine. So we generate this vector space for all of our documents. We generate the embedding, again, for our query as well. And then we end up trying to resolve the closest result. So for example, if Han Solo is my particular query vector in this regard, the closest two candidates are going to be Luke and Leia because they basically are the closest distance match features to those vectors. Does that make sense? Nods are good. This is an example of an ESQL query. You can also do it in Query SQL, Query DSL and Elastic as well. So you'll see from my Star Wars Movies Index, I'm doing a KNN query on the content field, and I'm generating a simple text embedding for this piece of text here, and I'm utilizing the Gina Embeddings v5 model. So that's a really simple example of a vector query, utilizing k-nearest neighbor search, which will return the closest candidates. But we still need lexical retrieval, because lexical retrieval is good at exact matches, whereas vector is around semantic matches, so getting the notion of context and nuance. And lexical retrieval, for anyone who's not familiar, is based on this data structure here, which is called an inverted index. It's basically a hash map. So you've got the terms that are extracted from your documents that basically we have a reference to alongside the document in which they reside. Really simple and straightforward. When we end up having this, you'll end up seeing that when we actually perform the query, which will utilize a particular matching algorithm, BM25 is the one used by Elasticsearch and Lucene, we'll match based on the extracted tokens to calculate a score and return the relevant documents that match this query. Really simple and straightforward. Now, people keep telling me, oh, but you don't need lexical anymore. We just use vector for everything because it gets semantics right. Wrong. If you're looking for exact matches, if you're looking for Millennium Falcon, that's an exact term. Lexical is probably going to perform better. But it can also be a useful thing as pre-filtering. So this is an example of a query DSL query where I basically have a pre-match, which is going to reduce the size of the vector space using lexical, and then I can go off and do the vector comparisons instead. We can combine them together. So this is an example using the fork operator where I've got each of the two queries that we've just talked about. But when we do multi-query like this, we need to figure out how to basically match the scores together from the different algorithms. Traditionally, we've done that using linear combination, which is basically where you'll take a weight or a factor, such as fork 0.7 here for my first query, and then we'll basically add that as a boosting factor when we surmise up all the scores to say that particular algorithm has more prominence. The problem with that is that we need to figure out what these weights are. It's not like magic 42. 42 is always going to work because it's the meaning of life. We need to figure out what this particular value should be based on our queries. Now, one where we can use sensible defaults is an algorithm known as reciprocal rank fusion, which is where alongside a sensible default constant of k, which we normally set to 20, where we can actually surmise all of these algorithms together. And it's actually the default in Elasticsearch. So when you use our fuse, RRF will work that way as well. But sometimes we have a fixed pipeline and we want to try and make sure that, we don't want to rip it apart. We want to maybe add additional nuance or recalculate the scores. And that's what re-rankers models are for. So basically what happens is it's a machine learning model that's been trained on tons of data, and it's able to score a set of retrieved documents in order to re-rank them and provide a particular order. There's loads of re-rankers out there. There's also Gina v3, which is the one I suggest to try out. It's available in Hugging Face, and it's also available in the Elastic Inference service as well. So you can try it out for free yourself if you'd like to. Now, RAG is changing and evolving. It's not just about this fixed pipeline anymore, because with agentic RAG, we move away from the notion of a fixed pipeline and into the notion of tools that can be called if the LLM says that it's necessary, and can also be called multiple times. So this is a simple search tool, which is basically pulling in the relevant documents that we're going to pass into our context. And it can do this potentially multiple times, or even none if it's considered to be not important. But it's not just about search anymore. It's about curating all sorts of different pieces of context, from files from our file system, the loading of skills, databases, web search, memory, as we talked about with context engineering, and shells, and using that to curate the right context and allowing the LLM to pull these things in as it determines they're necessary. Now, we can end up with problems with the amount of tools. If we give it too much, we can bamboozle the LLM and it might not have the right context. But we can also give it too little. And with both of these problems, we end up with a situation where it can call the wrong thing, it can call no tool at all, or indeed, if we don't give enough information, it calls it with the wrong parameters, all of which can be problematic and mean your agents are not going to be as efficient. So in order to make sure they call the correct tool, we need to consider prompt engineering the description. I like to use this particular guide from my colleague Leonie about the core purpose, the triggers, what it's meant to do, the limitations, relationships, and examples, which help it understand what parameters need to be passed, and make sure it's reinforced in the agent system prompt so that you connect these things together. Another thing I like to do is make sure that I mention similar tools and relationships and highlight the difference between them too. With that, combined by trying to find the right set of tools for our system, we're going to end up retrieving the right information. And we need to think about the notion of general tools, which are ones that can probably generate, query code for us programmatically by themselves, rather than relying on one that we've written ourselves. The general purpose ones have more flexibility and can kind of expand for multiple different problems, but obviously they need a bit more kind of nuance and they need a bit more they're a bit more difficult to use. But with the more generic ones, more specific ones like get top products by category, you're defining what that is, which can be fine if you want something really specific. But if your agent then has to do something a bit more generalized, it's going to struggle because it won't have access to the tools that it needs. So that's what we've covered. We've covered about retrieval, the notion that LLMs make things up, and part of our job is now looking at what context they have been given access to. We've talked about RAG. It's not just about the fixed pipelines anymore. There's also agentic RAG, which leverage tools as well. We've briefly touched on re-ranking models and how they can be quite useful for rescoring on top of an existing pipeline. And then we've also talked about context engineering. So all those things at the start, you can walk out the room saying, hey, I know what these things are now. This is cool. That is me. Thank you very much. We don't really have time for questions, so come find me outside afterwards, or I'll be at the Elastic booth if you want to come say hi, and thank you for listening.